Okay, so in this torque review question, we have a situation where we're holding a pen horizontal with your thumb pushing down on one end and your index finger pushing upward from the thumb. A certain distance, the pen is 0.14 meters long. Find the magnitude of the force of your index finger. So some students can struggle with reading what this actual question means. So if you take the pen, holding it, pushing down on one end with the thumb and pushing up 0.35 meters with the index finger. So sort of like this. So if I draw a picture of the pen itself, I sort of like model it as a uniform rod. We've got three forces on the pen. So you're pushing down here with, so this would be F thumb. It's a 0.14 meter long ruler, or sorry, pen. So about halfway along here, there is a weight force. And so weight force on the pen by the earth. And the way these numbers work out, so this is this distance here from this end is 0.07 meters because it's a 0.14 meter pen. So the thumb force acts exactly the index finger force acts exactly halfway between the center of mass and the end of the pen. So that's just the way the numbers work out. This is roughly 3.5. So put the pen or the index finger force there. So this would be F of the index finger. Okay, and this is our problem. So we can look at this from a torque example. We're trying to find the index finger force. So I can figure out the weight of the pen by using its mass, but I don't know how big the thumb force is. So this is a good location to put the pivot or axis of rotation. So the torque due to that force is 0 about that pivot. So about that pivot point, the index finger tends to rotate the pen in a counterclockwise direction, and the weight tends to rotate clockwise. So about this pivot, I would like these two torques to have the same absolute value. So I'll set the torque of the force of the index finger equal to the torque due to the weight force. And here again, the moment arms are exactly 90 degrees to the forces, so we don't need to worry about any the sign values. So we just need to figure out the size of the R values. So this would be equal to RFI times FI equals to R weight times the weight. So FI would be equal to R weight over the weight divided by RFI. So this would be equal to half the length of the pen, so 0.035 meters. Oops. So here 0.028 kgs. And 9.81 meter per second squared. All divided. Sorry about the mess here. All divided by the R for the FI. Oh, I definitely made a mistake here. Yeah, I did. Sorry. This should be 0.07 meters, half the length of the ruler. So just to repeat this, sorry, I was focusing on the 0.035. So the index finger force is RW, so RW is definitely half the length of the pen. And so this distance here is 0.07 meters, and this distance here, of course, is 0.035 meters. So I should have the correct distance in here of the RW. The weight would be 0.028, the mass is in kgs, times g, all divided by the 0.035 meters. And that should give you an index finger force of 0.55 newtons. So choice.